Hello, statistical scholars, and welcome to another Minitab episode of Hey, let's do some statistics. Today's video is going to be dedicated to doing some things with confidence intervals for means. I'm going to try to get through, I'll be honest, the second example is too long, so I'm going to just do this first example that I have up here, and then I'll move on to the second one. So I'm going to read my way through this. If you know how to read, you don't have to listen to this, and you'll skip ahead. The coffee machine company in your company break room dispenses coffee into paper cups, and you're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. Here are the measured amounts of the samples of 20 cups. Is there evidence that the machine is shortchanging users? Now, this is an interesting question. Now, when I go to supply evidence for whether or not something is true, usually I go directly to, hey, let's do a hypothesis test, because that seems appropriate in testing something that seems to be a claim, like there is 10 ounces of coffee on average, or stuff like that. But instead, we're going to do a confidence interval today to see if, the average cup of coffee is actually 10 ounces, for the proportion, or sorry, for the mean, actually shows up in the confidence interval. Because if it does, that might be some evidence for it. But if it's also got quite a few values that are less than 10 ounces, that also would be evidence against. So we're going to do a confidence interval. Now, I have taken the liberty of already opening Minitab and typing in this data. Woohoo! And I had my office mate double check it to make sure that I didn't have values that, double duplicated or missed or any of that. Another quick check to make sure you've typed everything in correctly is notice that it says there are 20 data values, and if you do look at this, this is a 1, 2, 3, 4, 5 by 1, 2, 3, 4, and 4 times 5 is 20, so there are 20. Oh crap, I even told you it's 20. Yay! Oh, and it's a random sample, so this is an appropriate test to be using. Aha! Let's do our confidence interval. So the confidence interval for means can be found in the stat basic statistics, and then I'm going to use the one sample t-test because my sample size is 20, which is not very large, and in particular my standard deviation for the population is not known, so this is the appropriate test to be using. Alrighty. Now I only have one column of data, so that part should be easy, and then I'm not performing a hypothesis test, so I'm leaving that all blank. And I'm going to do a 95% confidence interval, and notice I'm choosing not equal to because confidence intervals are two-tailed in general unless you tell them not to be. You can do one-tailed confidence intervals, but they're not that interesting. But I want a actual confidence interval, so it's, centered about the sample mean. I'm going to click OK, and then click OK a second time, and it'll give me my confidence interval. So you look at this, oh, the mean is only 9.8, it's actually not 10. And in particular, when you look at your confidence interval, 10 ounces isn't even in there. So you could say, hey, I am 95% confident that the coffee machine fails to produce 10 ounces on average. And I'm going to say more than that. I would say the amount produced on average is actually between 9.75 ounces, that's a 0, not an O, and 9.94 ounces, and I'm doing 2 decimal places here because I want whoever reads this to be like, so I can actually even tell you like a low end and high end on how far off it is. Like it might be, a fourth of an ounce off, but it might be only 0.6 off. But either way, it's still not going to be 10 ounces 95% of the time. So you definitely have got some evidence that this is wrong. Notice I didn't have to do a hypothesis test to do that. So sometimes it's a good idea just to do the confidence interval first and then worry about the hypothesis test later. I am going to save number 2 because I've already seen how long this video is for next time because this will take me a while since there's multiple parts. So we're going to be looking at batteries next time and evidence, and lifespan. And notice this last question is all about sample size, which means I'm probably going to be using margin of error. Remember, it's always a good idea to read a question first before you actually attempt it so you know what you're going to be asked. That's all for now. Ta-ta!